Hello, everyone, and thank you for joining this session. I'm Juanjo Hierro, Chief Technology Officer at the FIWARE Foundation, and I'm very glad to be here with you. I'm going to talk about the need to define open standards for digital twins and what we are doing at FIWARE in that direction. Digital twins bring a quite powerful paradigm to approach data integration at multiple levels. First, it brings a paradigm how you may architect your smart solution, integrating the different components in a multi-tier architecture. For example, how you architect a waste management solution in a city, or a predictive maintenance solution for wind turbines in a wind power plant. Second, it brings the means how you may break the information silos within organizations, providing the basis for implementing a system of systems approach, for example, in a city, or a factory, or a grid operator. Third, it brings the means for implementing data spaces, enabling a trusted and effective exchange of data between smart systems of different organizations. Following an implementation-driven open source approach, FIWARE's mission has been contributing to the creation of open platform standards that ease the development of smart solutions and the digital transformation of organizations into smart organizations. And because digital twins are so essential in this respect, the FIWARE community, the support of the FIWARE Foundation, has devoted significant efforts to drive the definition of the core standards for digital twins that the market needs. But what are we referring to as digital twins? Let's agree on some concepts. A digital twin is a digital representation of a real-world asset. This typically maps to some concrete physical object or entities, like a room or a car or a shop, with a person. But it also can refer to digital entities which may not have a physical realization, but still are quite real. Think about a claim ticket issued by the customer of some retailer, which is stored in its CRM system. A digital twin is characterized by attributes, some of them being properties that describe the state of the asset, some others being the relationships with other assets or entities. Values of these attributes may change over time or be static, and many of these digital twins may be associated with certain physical location. Two aspects are key if we want to achieve true interoperability and portability of applications. In the first place, we need a standard API for getting access to digital twin data. Second, but equally important, common data models which define what are the attributes that describe digital twin classes. And both are equally important. Without any of them, we would be sacrificing portability or interoperability of applications. The FIWARE community has driven standardization and adoption in these two fronts, and we are proud of having contributed to first, the definition of the Engisild API, which is the only open standard API for digital twin data access that exists out there, available as open source, with a relevant level of adoption. Second, the creation of the Smart Data Models Initiative, where we are compiling the mapping of standard data models or data models being contributed by the community into JSON and JSON-LD structures compatible with Engisild. Engisild was first implemented within the FIWARE community in the context of several projects, and in 2018, we brought it to a reputed standard body called ETSI to evolve the API, incorporate support to linked data, and create the Engisild standard API specifications we have nowadays. The context broker is the core element in any Powered by FIWARE architecture, and this component implements Engisild to provide access to digital twin data, but also bring the means for creation of digital twin entities and the way to update values associated with digital twin attributes. Think about a city. What is going on in near real time is represented by the context, which is nothing different than a collection of digital twins of different types. We have buses with attributes that might be quite static, like the license plate, or they're quite dynamic, like the number of passengers, or the location, or the speed, and others that are variable but not changing so dynamically, like the ID of the driver. And there are other entities like citizens, shops, incidents, tickets, and so on. All together with their state bring a representation of what's going on in the city in near real time. And this approach is totally general purpose. So it works for cities, but it can also work in agri-food, in health, in factories, or in energy. We say that Engisild is a simple yet rather powerful RESTful API. We say that it's simple because it brings a set of operations that are the kind of operations any web developer would expect from a RESTful API, modeling digital twins and digital twin attributes as unique resources on which you perform standard post, get, patch, delete operations. Actually, we have seen how experienced web developers can start creating their very first FIWARE applications in the very first day of their training. But we say that it is also rather powerful because it brings support to quite powerful features like geo-queries, subscription notifications, the ability to connect to sources of data in either pull or push style of communication, the ability to select what kind of JSON LD rendering I want in responses, or the ability to perform time series operations. The second key area where FIWARE is delivering the kind of the standard mechanisms that are needed are the smart data models. Here, we have launched the Smart Data Models initiative, targeted to provide developers with the definition of data models mapped into JSON or JSON LD structures that are compatible with Engisild version 2 or Engisild LD, respectively. Data models published under this initiative are either generated by means of mapping relevant standards using tools we have developed. A sample of that could be IEC in energy, or based on contributions coming from teams involved in projects where defined data models can be tested. I encourage you to visit the Smart Data Models on GitHub to discover more. You will find there repos associated to subjects like parking or weather, and repos associated to relevant domains like smart cities, smart agrifood, smart energy, smart manufacturing, and many others. Some subjects may be relevant to several domains. That is the case of weather. Models evolve based on merits from incubated to full graduated, going through an intermediate step focused on harmonization. And all data models are public and royalty-free. Despite FIWARE was born in Europe, the initiative was designed to target a global adoption. This slide mentions 3 relevant bodies that decided to embrace Engisild as a standard API for getting access to context digital twin data. We have ETSI, which I had introduced already. We have GSMA that brings together all mobile operators around the world. And finally, we have to mention TM-Forum. The last two have not only adopted Engisild as a standard API, but also have contributed relevantly to the definition of smart data models. In addition, it is worth mentioning how Engisild is being recommended at region or country level. In this respect, it is worth mentioning that the European Commission has adopted FIWARE Context Broker technology as one of the building blocks that are part of the Connecting Europe Facility program. This means that the European Commission officially recommends organizations, starting with public administrations, to use this technology, therefore NGSI, as the basis for creation of digital service infrastructure for sharing context digital twin data in near real time. Goal is to enable the development of digital services which can interoperate and be replicated across member states in the European Union. On the other hand, the Ministry of Housing and Urban Affairs in India has launched an open source initiative called IOTSWC, targeted to deliver the platform that cities should use for data exchange within and across cities. The IOTSWC platform has adopted Engisild as standard API for data interchange, and the UDX organization has joined the Smart Data Models initiative. Now, let's take a quick overview at how architectures powered by FIWARE are defined across the 3 different levels of integration following a digital twin approach. And here you can see more details how a smart solution that gravitates around the digital twin paradigms looks like. For example, a smart waste management solution in a city. You can see an architecture where components are organized in 3 major layers, where a context broker is placed at the core layer dealing with management and access to digital twin data representing that part of the real world that the smart solution is dealing with, and 2 additional layers. One layer southbound, coping with the gathering of information coming from multiple sources, like IoT devices, cameras, robots operating in the field, or information systems. Another layer northbound, dealing with the implementation of data monitoring functions and analytics, or processing functions based on the application of the most advanced big data, complex event processing, or artificial intelligence and machine learning techniques. Digital twin data does not only flow from the southbound to the northbound, but the other way around, and this is very important to highlight. Actually, results from big data analysis or from predictions based on machine learning techniques are incorporated to the digital twin representation of the world, enriching that representation with inferred knowledge. Thus, for example, the digital twin of a street does not only contain an attribute with the current measured traffic, but also an attribute with the traffic that is predicted in the near future, whose value is obtained as a result of predictions based on machine learning techniques. Southbound components, on the other hand, not only update attributes of digital twins, but also receive notifications about updates on certain digital twins and this may translate into actuations transferred to IoT devices, robots or cameras connected to the physical world, or different information systems. Very important are components dealing with identity and access management, working across all layers, which govern what attributes from what digital twins can be accessed and from whom. FIWARE brings open source components in the mentioned three layers, not just the context broker facilitating the creation of digital twin-based architectures. However, FIWARE is not about taking all or nothing. You can pick up only certain components and combine them with your favorite platform components, being open source or not. The only component that is mandatory if you want your architecture to be truly powered by FIWARE is that a context broker is in the middle, managing access to digital twin data. And architectures like the one described here for a waste management solution in cities can work for solving challenges in other domains. See, for example, a warehouse transport robotic system, where elements like the different vehicles in the shop floor, including AGV robots, or the shelves where products are stored, are modeled as digital twins. The system interfaces with different IoT sensors, cameras, robots, and information systems, like the system dealing with the inventory of products. The architecture is equally applicable in smart agri-food solutions, where elements like crops, fields, tractors are modeled as digital twins, and the system interfaces with different IoT sensors, cameras, agri-machinery, including robots or drones, and information systems like weather services. Or smart energy solutions like a wind power plant management solution, where the elements like the wind turbines, energy storage systems, the overall wind plant, or the e-charging network are modeled as digital twins, and the system interfaces with sensors, cameras, monitoring devices, and information systems like weather services or energy marketplaces. Let's see a real example, a solution developed by a startup called Elliott Cloud.
Hello, my name is Sandra Orduña. I'm one of the owners and CFO of Plástico Sima. Sima is a company established in 1999. We manufacture plastic pieces through injection, making use of our own designed molds under request or third-party molds. The main problem we try to solve is the clogging or adhesion of material to the mold in plastic injection processes. This problem affects productivity because it involves stopping production to unscrew the parts, material or castings stuck in the mold. The AgilPlus project has allowed us to have two productive elements connected, the injector machine and the robotic arm. Through this connection, our team is able to visualize the data coming from this equipment in a dashboard, and thus we have a real-time decision system on the production of plastic pieces. We are currently analyzing the long-term impact of the AgilPlus project. Besides, thanks to the implementation of the project, the plastic injection production process has been improved, and we have been able to increase the calculation overall equipment efficiency of our production in more than a 10% and our quality rate in more than a 3%.
Was very nice, right? Elaborating now in how digital twins can be used to break the information silos within a given organization, following a system-to-system approach, this slide presents the reference architecture of a smart factory, bringing the basis for integrating different systems in the shop floor, and the opportunity to implement manufacturing execution systems, which can rely on standard digital twin interfaces and also interact with demand planning systems or supply management systems in a standard way. Just think about the potential derived from creating standard digital twin models and standardizing certain processes like palletizing of products or pick-and-place functions. Same happens in Agrifood. In this case, we talk about digitizing a farm and the possibility that FIWARE brings implementing a digital twin-based approach for integrating the different applications coping with different processes within the farm. In this case, part of the digital twin data managed in the farm may be shared with third parties relying on data marketplaces and publication platforms, bringing new opportunities for farmers derived from offering their data to companies that produce soil fertilizers, for example, eventually being able to monetize it. Also pretty interesting is the capability to integrate digital twin-based systems like the one described here with distributed ledgers or blockchain technologies. Actually, FIWARE brings components using the storage of logs associated to digital twin data transactions into different kinds of distributed ledgers, paving the way for auditing processes, therefore certifying the quality of those processes, which is rather important when we talk about the agri-food chain. And that is the same for energy or for smart cities. Tackling the third level of data integration, a digital twin approach enables a full data economy based on exchange of digital twin data among different organizations. So we can think about smart cities exchanging digital twin data with the smart ports or smart buildings, including malls, and all of them connected to improve their respective processes and optimize the value chain, which may deal with delivery of goods that arrive to a port and need to be transported to malls in a city. This is the concept of data spaces for the data economy, where multiple organizations will be sharing a digital twin representation of the world, each one contributing with part of the data they manage, and also be able to rely on data other organizations are sharing. Some organizations may decide to share part of their data with a price, therefore enabling data trading among participants. That's why data service marketplaces can be part of the game. Last but not least, this kind of data spaces must guarantee that exchange of data takes place in a trusted manner and that participants can exercise full sovereignty on their data. Fiverr brings the basic building blocks to build this kind of data spaces. Let's see another nice video.
The demand for energy today is high and still growing, a global challenge affecting everyone and our planet. This is why European partners Germany, Sweden and Romania in the FISMET project joined forces to co-create solutions for a smarter energy future. The platform they use is cloud-based, service-oriented and open source, giving rise to a new European standard, FIWARE. In Sweden, the project team, Chalmers University of Technology, the City of Malmö and E.ON developed and tested new efficient and user-friendly energy services. Chalmers University of Technology developed Aero, an app that enables end users to monitor, plan and control their energy use, affecting choices related to cost, CO2 footprint and energy mix. Simultaneously, E.ON developed CISO, a smart platform using thermal inertia in buildings and power control for peak shaving. Through FIWARE, field tested in Malmö, the researchers can connect both end users' input and smart grid management to the energy system. As a result, in periods of high energy demand, consumption peaks can be shaved. Less peaks in the grid reduces the need for non-renewable energy sources and contribute to a more sustainable energy supply. Connecting Aero and CISO to more buildings globally will accelerate the shift towards more sustainable and smart societies. FISMEP shows that both individuals and smart grid operation have a part to play in the creation of future sustainable and smart cities. Let's be bright together.
The FIWARE community is continuously evolving the technology based on the demand of real use cases. This slide elaborates on the several working groups that are tackling different roadmap activities. Evolution of the Engisild API to make sure it brings the best digital twin data access API for developers. Definition of common data models, which combined with the Engisild API warrants interoperability and portability of applications. Everything that has to do with integration with distributed ledger technologies, including blockchain. How to architect systems incorporating AI, machine learning service, exploiting digital twin data, and supporting plug-and-play integration of AI ML services in systems. How to integrate with robots, and how to materialize the concept of data spaces and data marketplaces supporting a data economy. FIWARE brings technology as we have seen, but technology is not the only aspect that justifies why FIWARE is your best option. A growing ecosystem around the technology that ensures you won't get locked in any vendor, a vibrant community behind, not only involving those who contribute to the evolution of the technology, but a network of digital innovation hubs, called FIWARE hubs, which are engaged in transferring know-how at local level within their regions. Also, the FIWARE Foundation bringing the support to this community and the development of the ecosystem, protecting the brand and doing for the common good. All these aspects are equally important as technology and sustainability is something that should govern your decisions. Now, I leave some conclusions to finalize this presentation. FIWARE brings response to existing challenges regarding interoperability and replicability of smart solutions in multiple sectors, relying on a digital twin vision and supporting system of systems and data spaces integration. An approach paving the way for the connection of systems across domains that is future-proof, and don't forget, FIWARE is open for all, forever. Thank you.